I'm going to work through each answer on the pretest that was sent out. You should first work out the questions yourself and then go to the pretest to see if your answer is correct, and if it's not correct, to see how to work it out. So this pretest is based upon material that you should know coming into differential equations. And this contains items that I see students making mistakes with all the time. And they're generally little mistakes that if you think about it, you know better. But a lot of times you're just not thinking about it. Anyway, the first question is just an algebraic question. You're solving an equation that contains natural logs. 2 natural log of the square root of x minus natural log of 1 minus x is equal to 2. So whenever you see natural logs, you want to think limited domain. There are certain values that x cannot be. It's not possible to take the natural log of 0. It's not possible to take the natural log of a negative number. And that's going to limit your domain. And so notice that I have restrictions on x. From this first term, the natural log of the square root of x, we know that x has to be greater than 0. And from the natural log of 1 minus x, we know that 1 minus x has to be greater than 0. If I take this second inequality and bring the x over to the right side, I get 1 is greater than x, or x is less than 1. So x is greater than 0, and x is less than 1. So any solutions to this equation has to be x values in between 0 and 1. Now, to solve this equation, one way that you could solve it is to start by combining the natural log terms on the left side. To combine these natural log terms, we first need to get rid of the 2, and you can do that by bringing it into the exponent. It's called the power rule for logarithms. So if I bring that 2 into the exponent, that gives me the natural log of the square root of x squared minus the natural log of 1 minus x is equal to 2. And the square root of x squared is just x. So now I have the difference of 2 logs. And with the difference of 2 logs, you can combine this using what's called the quotient rule for logarithms. The quotient rule for logarithms says to combine these 2 logs, I need to take the quotient of the arguments of the logs, or rewrite this as natural log of x divided by 1 minus x, and then it's equal to 2. So now to solve for x, I need to get the x's out of the argument of the log. And to do that, you can apply the exponential e to both sides. Essentially, you'll have e to this natural log of x over 1 minus x equals e to the 2. And e to this natural log, those are inverses of each other and cancel each other out, to leave you with just x over 1 minus x is equal to e squared. And we need to solve for x. So I'm going to bring this to the next page. And start by getting rid of the fraction. I'm going to multiply both sides by 1 minus x. And that'll leave the x by itself on the left side. On the right side, you get e squared times 1 minus x, which you can distribute through by the e squared. To get e squared times 1 is e squared times x is x e squared. And again, we're solving for x, so we need to get these x's together. I'm going to bring that xe squared over to the left side. That'll make it positive. X plus xe squared equals e squared. And now on the left side of the equation, I can factor out an x to get x times 1 plus e squared is equal to e squared. And now solve for x by dividing by 1 plus e squared. You get the answer for x. So the question is this value in between 0 and 1? And I say, yes, it is. You can type that into your calculator if you want to, or just think of e squared as really any number you want it to be. If we know that e is about 2.7, so let's round that up to 3. If e is 3, 3 squared is 9, and then 1 plus 9 is 10. 9 out of 10 is between 0 and 1. And really, e could be any number. E squared over 1 plus e squared, as long as e isn't 0, is always going to be a number between 0 and 1. Okay, so this is our answer for x.